All right, let's get started today. Um, so this week, we're going to continue with that idea of factoring. Um, Today, we're going to look at finding a greatest common factor. And then at the end of the week, we will um, factor uh, polynomials into binomial factors. So I think the idea of factoring is what many people associate most with algebra. If you ask someone what is algebra, they'd probably think, or one of their thoughts would be about this thing that we call factoring. So that's the idea. That's what we're going to do for the next couple days. A reminder that if you have any 4.5 or 4.6 homework, that is in the chapter 4 folder, and anything from 7.1 to 7.3 is in the chapter 7 folder. So you want to make sure that you get that done so that the hope is that we get you a math credit, and my hope is that you do well and enjoy math. So we're gonna get going on 7.4, which is factoring polynomials with the greatest common factor. And so there'll be a lot of what we did on Thursday last week, you'll see with today's work. So that's another reason why staying current on your homework is a good idea. That whole building block idea. So factoring polynomials using a greatest common factor. So this idea, greatest common factor, it's the largest number that divides evenly into two or more numbers. So finding the greatest common factor of 12 and 30, one way to do that is to take 12 and 30 and factor using those rules of, or those rules for factoring, rules of divisibility. So 1 and 12, 2 and 6, 3 and 4. And if we go to 30, again, always starting with 1, 1 and 30, 2 and 15, 3 and 10. 4 doesn't work. 5 and 6. And now the greatest common factor is the largest number that is in both of your lists. So it looks like 6 is my greatest common factor. So part of what we will be doing is finding the greatest common factor for our coefficients, our numbers in front of our variables, but also determining if we have a variable as our greatest. So here we have 12x to the 5th, 8x to the 4th, plus 8x to the fourth minus 6x cubed. Notice, first of all, it is in that standard form, which we like. That's actually going to make the process a little bit easier. So the first thing we need to do is figure out the greatest common factor with the coefficients. So the largest number that divides evenly into 12, 8, and 6. And again, if you want, you could list out those factors. 12 would be 1 and 12. Let me rewrite that. 2 and 6, 3 and 4. 8 would be 1 and 8, 2 and 4. So at this point, I would and look at common factors for 8 and 12. They both have a factor of 2. They both have a factor of 4. So our greatest common factor has to either be 2 or 4. And now we'll look at our factors of 6. And we see that 2 is the greatest common factor. For the coefficients, the greatest common factor for the variables, if your expression is written in standard form, is very easy. Look at the last term. If it has a variable, that variable will be the greatest common factor. So this has an x cubed. Okay. So it's the, all the terms have to have a variable for the variable to be the greatest common factor. And it's going to be the variable with the smallest exponent. So in this case, as I said, it's x cubed. So altogether, for 12x to the fifth plus 8x to the fourth minus 6x cubed, our greatest common factor is 2x cubed. All right. So what I would like for you to do, go ahead and try these two problems, factoring out the greatest common factor. And so all you're doing, finding the greatest common factor. We'll change it up a little bit with the next part, but go ahead and find the greatest common factor for each of these two expressions. And I'll give you a few minutes to work on it. So the one of the reasons factoring out a greatest common factor is helpful is it makes the polynomial easier to work with, I think. Easy. Try this again. You know, it makes the coefficient smaller, the variable smaller. It just is easier, I think, to work with and to see. So the difference that we're going to do now, here it says factor out the greatest common factor. So now instead of just writing what the greatest common factor is, we are going to write it and rewrite what's left in our polynomial. So 4x minus 12, finding the greatest common factor. Again, if it helps, list out the factors. 2 and 2, again, you could just list the 2 there once. And the largest number that is common to both is that 4. So we're going to write the common factor, and then we're going to put parentheses in. And what we're going to do is divide the coefficients by the greatest common factor. So 4 divided by 4. Well, go ahead and either shout it out to me or put it in the chat. What is 4 divided by 4? Kind of easy to see if you write out your common factors, right? 4 and 1 are factors, so 4 divided by 4 has to be this other factor, 1. So I have 1x. 12 divided by 4 is 3. So here is my expression, my polynomial with the greatest common factor factored out. And again, you don't have to write the 1. You certainly can. You don't have to. There is no variable in the greatest common factor because this second term doesn't have a variable. So sometimes you'll have a variable, sometimes you won't. So take a look at this one. Factor out the greatest common factor. And I will tell you, for me, if my lead term is negative, I'm going to factor out the negative. So that's going to be part of my common factor. And then I'll just factor the numbers without the sign. 12 we've done a few times. 18, 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, and then I'm back to 6, 27, 1 and 27, 2 doesn't work, 3 works, 3 and 9, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, so we're done. Those are our common factors for the coefficients, and the greatest value that shows up in all 3 lists is the 3. Then we should also take a look at variables. Is there a greatest common factor with the variables? In this case, there is an x in all 3 terms. The lowest power of x is just x, x to the first. So factoring, I took the negative out with my factoring. So this 12, it's going to be a positive. It's going to be positive 4. And I had x cubed, x times x times x, but I factored out one of the x's, so I'm left with x squared. The 18x squared was positive. We factored out a negative, so it's going to change signs. And 18 divided by negative 3 is negative 6. So basically factoring out is like division. I had x squared. I factored out one of the x's. It leaves me with x to the first, or just x. Negative 27 divided by negative 3 is positive 9. I had an x, but I factored it out. So there would be my polynomial with the greatest common factor factored out. All right, so here are a few to work on. Again, factor out the greatest common factor, write it. Sometimes you'll see it, expressions or instructions will say write in factored form. But right now we're just going to worry about factoring out that greatest common factor. All right, so the greatest common factor, if we look at this first one, there's a coefficient of 1 in front of the x cubed. So the greatest common factor for 1, 5, and 21, that's just 1. There's not going to be a numeric greatest common factor. All of the terms have a variable. X to the first power is the lowest power, so we're going to have an x. And now we divide that out. So we had x cubed. We factored out 1x. That's going to leave us with an x squared. 5. We had x squared. We factored out 1x. Leaves us with x. Minus 22. We had an x, but we factored it out. And then if you want, you can double check, are there any other greatest common factors? In this case, there are not. That's our factored form. For the second example, 18, 6, and 24 are all evenly divisible by 6. And the x squared is the variable with the lowest exponent, and there's an exponent or a variable in each term. So now it's just division. 18 divided by 6, that's 3. We had x to the fourth. We factored out 2 of the x's. We're left with x squared. 6 divided by 6 is 1. We had x cubed. We factored out 2 of the x's. That leaves us with x. 24 divided by 6 is 4. We had x squared. We factored out 2 of the x's. So there's our expression. The third example, greatest common factor 3. X squared is the lowest exponent. 3 divided by 3 is 1. X to the fourth, we factored out x squared, leaves us with x squared. Negative 9 divided by 3 is negative 3. We had x cubed, we factored out x squared, leaves us with an x. 12 divided by 3 is 4. We had x squared. We factored out that x squared though, so it just leaves us with 4. Last example, each of the terms here end in either a 5 or a 0. So 5 is going to be a greatest common factor. And x is our, we have an x in each term, and the lowest exponent is to the first. 5 divided by 5 is 1. We have x to the fifth. We factor out one of them, leaves us with x to the fourth. 35 divided by 5 is 7. We had x cubed, factored out 1, leaves us with x squared. 50 divided by 5 is 10. We had x to the first. We factored out that x. All right, so the last thing that could happen is we could have more than one variable. So what is the factored form of 3x cubed y minus 12xy cubed. Starts the same way. Factors of 3, factors of 12. The greatest common factor is 3. So we're going to have a 3 as a greatest common factor. Then we look at the variables. I have x cubed and x. So if I look just at the x's, the smallest x is this x to the first. So I'm going to have that as one of my greatest common factors. Then I look at the y's. I have y and y cubed. So the smallest, I have y's in each term. So the smallest that I have is a y to the first. Take 3 divided by 3, that's 1. I had x cubed, I factored out an x, it leaves me with x squared. Negative 12 divided by 3 is negative 4. Oh, sorry, I had y to the first, and I factored out the y in that first term. Here I had x, but I factored it out, so I'm not going to have an x there. I had y cubed, but I factored out a y. Leaves me with y squared. So the key there is there's an x and a y in both terms. All right, with 50x squared minus 32y squared, 50, again, the factors, 1 and 50, 2 and 25, 5 and 10, 32, 1 and 32, 2 and 16, 4 and 8. The greatest common factor is 2. Here I have x squared, but no y's. Here I have y squared and no x's. So they don't both have the same variables. So there's not going to be a variable in my common factor. 50 divided by 2 is 25, and I still have the x squared. Negative 32 divided by 2 is negative 16. I didn't factor out any variables, so I still have y squared. That is my greatest common factor.